This is one of those classic AP Calc questions that gives you some information about a function and then gives you a whole bunch of statements about what must be true. And so on this one, we look at this and they're telling us first and foremost that this function is continuous on this closed interval right here. And then they're just telling us that we have these 2 points, these 2 dots. When x equals 0, y equals 7 is on there. And when x equals 2, y equals 16 is on there. So whenever I go through these, I start and say, okay, well, what do I know? Well, if somebody tells me that something is continuous, kind of the big things that I can learn about that is the definition of continuity is the first thing. So I know that at every point on that interval, the limit as x approaches a of that f of x equation is equal to f of a. The limit is going to equal where the actual dot on the graph is located, where the y value would go. The second big thing you want to look out for when we're talking about continuity, there's really just one big theorem that comes from this continuous section, and that's going to be your intermediate value theorem. And the reason that we look at this is because the intermediate value theorem says if your f of x is continuous, and that's all that's required out of it, if it's continuous on a closed interval from a to b, then you're kind of guaranteed that you get every value between those two endpoints. So in between there, you're going to be guaranteed every y value between those two endpoints. So the idea behind the intermediate value theorem, right, if we just kind of look at it on a graph, is if I start at some point here at a, there's my f of a value, that y value, and then I stop at some point b out here and I have an f of b, that y value, that I am absolutely guaranteed to get every y value in between those two. And that's all that I can really say with 100% certainty. So what you want to do is kind of go through each of these options one at a time, seeing what holds true. And keeping in mind that when we do this, the key on this is that it must be true. It has to 100% absolutely be true. It's not, could it be true? There's a lot of things that could happen, but there's a big difference between what could happen and what you are absolutely guaranteed to happen. So let's walk through our options here right now. So as I look at option A is saying that there is a y value that f of 1 has to live between 7 and 16. Well, that's where they're kind of trying to play off this idea that we have 7 and 16 going right there, and 1 happens to live in between 0 and 2. Well, could it be in between those two things? Absolutely. Are we 100% guaranteed that that value has to be there? No. Any number of things could happen between this y value of 7 and this y value of 16. Your graph could go past it, below it, all over the place. And so you are not guaranteed that that y value right here has to live between the two y values that we know about. The next one is sort of a trap little question. They're saying f is increasing on this interval. Well, when they say it like this, they're saying it is strictly increasing, that it never has a decreasing section. And so while we know that to get from 7 to 16, we definitely have to increase at some point, there's nothing that says it always has to increase. This graph could go up and down and all over the place to get from one point to the other. So it could have a decreasing section. It is not strictly increasing this entire time. So we know that that's not true. Then we look at C, and C is saying that there is some y value where it has to equal 15 on our given interval. Well, this really is sort of taking advantage of our intermediate value theorem. If we look at option C right now, if I drew out just a little graph of what we have, I know that at 0, I would have this dot here at 7, and then over at 2, I would have a dot up here at a y value of 16. And so by the intermediate value theorem, I know that I'm guaranteed every y value between 7 and 16. The graph could give me other y values. It could go up and down all over the place. But I am guaranteed for sure that I'm going to get every y value between those at least once. And so C is absolutely 100% true. I know for a fact that 15 has to be on this graph because 15 is between 7 and 16. So that is my good answer. But just to make sure we understand why the other ones aren't right, we'll keep kind of rolling through this right now. Here they say that the derivative has to equal 9 at least one solution. So what they're trying to play off of us on D is they really want us to come and think about the mean value theorem, which uses this idea that the slope between my two endpoints has to equal the slope of the derivative at some point. The key part of the mean value theorem, though, that we're not being told right now, the mean value theorem requires two things. It's got to be continuous on the closed interval that we're talking about from A to B, but it also has to be differentiable on the open interval from A to B. And so they didn't state anywhere in this problem that we are guaranteed that it is differentiable. You could have a graph going between 0 and 2 that ends up with some sharp corners happening here. And if that happens, then at these places here, the graph is not differentiable. And so we are not guaranteed the outcome of the mean value theorem. So therefore, D would be off the table. And then if we look at E is talking to us about what the value of the integral would be. So the area between the curve and the x-axis. And again, we don't really know what this graph is doing. The graph, like we keep talking about, so on D, the graph could be going, on E, the graph could be going up and down. It could be going all over the place here as far as like what that area is between 0 and 2. And we don't know anything about that behavior. And so to draw a conclusion about what the actual area between the curve and the x-axis is, we'll never be able to do that given this information. So, like we said before, C is our good answer. And when we're talking about a continuous function, remember the two things that you can know about a continuous function when people tell you that are the definition of continuity and the intermediate value theorem. Those are the two things you want to be looking for. And always, always, always remember that you're looking for what must be true. Not what could be true, but what 100% absolutely must be true. Thanks for watching my video. If you liked it, please click that like button and subscribe. And also share it with your friends and anyone else you know who might be crying about an upcoming AP Calc test. You can find more videos from me, more sample AP Calc questions, and my complete AP Calc study guide over at my website, apcalcprep.com. Have a great one.